Hello.
Good morning, good afternoon, good evening, good night. Welcome to Spring Working Group. Please note the note well. By contributing to the IETF, you agree to follow IETF processes and policies, which are described here. So please have a look. Next slide, please. This is the agenda for today. We have a large part, 30 minutes at least. We could use more if needed. Dedicated to the SRComp design team update and analysis. So please feel free to contribute, because this is a topic for the working group now. Next one, please. So today's meeting, you can update the minutes by directly checking and correcting your name and comments and contributing to the Etherpad. In terms of queue management, you can enter the queue by pressing the raise hand icon, but you need to separately send audio to speak. So you need to send audio. Shares cannot send your audio. Otherwise, when not speaking, please mute yourself to avoid background noise. And finally, please remember that sessions are recorded and publicly broadcasted on YouTube. Next one, please. So we have a large slot on SRE6 compression design team. The design team has completed its work and published 2 drafts, one on requirements and one on compression analysis. And they will present the outcome in a few minutes. We'd like to thank the design team for the hard work, really a lot of work and lots of dedication. And now it's up to the working group to review the comments and to contribute and to own the work. Next slide, please. In terms of working group document on updates, we have a new working group document, which is draft IETF Spring stamp SRPM. There is a related document in IPPM working group. Sorry for the typo, which has been accepted by IPPM working group before we took it in Spring. In terms of IETF working press calls, we have 2 pending. One is draft IETF Spring NSH SR. There was a revised ID needed. It was published today. So please check whether your comments are part of it. And there is another one occurring right now, which is a draft IETF Spring MPLS pass segment, which is a draft to advertise pass segment in MPLS segment routing. Next slide, please. We have submitted one draft to ISG for publication, which is a segment routing policy architecture. So it's a big milestone for the working group. So thank you for the involvement from others and the working group. Next one. And finally, we have two documents in RFC editor. One is a young data model, which has been published as RFC 9220. And another one, which is currently in OS 48, which is segment routing centralized BGP e-peering. So it's quite an old draft. It was pending on dependency. I believe that's all. Next. Okay, so that's all.
We need the first.
So let's move to yes, let's move to the first presenter, which is the design team.
Do you hear me?
John, you no? Yes, we do.
Okay. So, Bruno, you will share the slides, right?
I have the slides shared right now.
Okay.
I believe this is the deck you need.
Or maybe there are some.
Make sure you are displaying the presentation.
Yeah. Okay, I got it. So
just tell me when to advance.
Yeah. Thank you, Charles. This is Wu Changcheng. I will present the slides on behalf of the design team. Any comments or question? Please interrupt me directly. Next slide.
Clarify, please put yourself on the queue in the chat. Jim will call on you. Do not interrupt unsolicited. We're going to use queue management because we hope to get lots of discussion.
Okay.
So everybody except the presenter, put yourselves on the queue when you wish to speak.
Yeah. So please next page. Okay. Here we list the two main tasks running in the design team. One is the requirement draft, and the other is analysis draft. After 1 year of hard working, the design team almost complete the planned tasks. We post the 07 revision of requirement draft, which are stable now. According to the requirement draft, we generated the analysis draft and posted the 02 revision. It included the analysis to each requirement item, and the text is now stable also. Let's go through the updates to the both drafts. Next page. Okay, let's go to the status of requirements draft directly. That's it. Next page. So here is the latest status of requirement draft. Compared to revision 5, in this version, we just remove the section 5.2 and change a few words. Next page. So this page you can see the section 5.2 is about PS or BCP compliance. According to the comments, the members of the design team agreed that this requirement is normal IETF rule that should be satisfied by default. So we remove that. Next page. And we direct to the status of analysis draft. So compared to the first revision of the analysis draft we've presented in last IETF meeting, we have updated all the sections. And now the revision 02 is a stable text. We think the document will help the working group to understand the proposed byte. Next page. Here is a brief introduction of the draft. It provides the detailed analysis of the 4 proposals. The first one is CSID, which gives the SF6 seed behaviors to support compression, combining the seeds from microseed and GSeed draft. And the second is CIH, which provide new routing headers and label mapping to IPv6 address and behavior. The third one is VSeed. Documents give a new or modified routing header for compression and how to build SF6 seeds. The last one is UIDSR. It documents a method, modified routing header with valuable length segments and label map to IPv6 address or IPv4 address. So let's go to next page. I think we will give some brief introduction for each draft. Yeah, this page is about the CSID. As we just mentioned, it's a combination of seeds from the both draft microseed and GSeed. CSeed doesn't need any SF6 data plan and control plan change, and leverage the SF6 network programming model. It provides 2 flavors. Next CSeed flavor reflect the microseed, and replace CSeed flavor reflect GSeed. Both of them are in the same framework. So next page. Yeah, this page is about the CRH. And CRH requires 2 new routing header types and the label mapping technical CRH, which defined 2 new IPv6 routing header, CRH16 and CRH32, and each seed mapping maps to CRH5 entry. There is no change to IPv6 forwarding plan or address model, and just change to SF6 data plan and control plan. Next page. Yeah, this page is for the VSeed. VSeed draft defines a set of seed behaviors to access smaller seeds within the SR V6 header. It's a very interesting solution. It generalized the SH for any size of the seeds and the prefix, and built on a common SF6 locator prefix as the formula here. It doesn't require any SF6 control plan change. It leverages the SF6 network programming model. In the next page. Next page. So this page is about the UIDSR solution. It give comprised SF6 segment list encoding in the SRH. It introduced a UET flags to unify the traditional SF6 seed and unified seed forwarding behaviors. When the UET is 00, it represents the classical IPv6 address. When it's 01, it will be a 32-bit shorter IPv6 address. When it's 10, it will be index for MPR's labor. If it's 11, it will represent 16 bits shorter IPv6 address. So above 4 pages provide some brief introduction of the solutions. I think those 4 solutions are all complete solution for the comprising. The next page. This figure is a typical reference network for the analysis. An ISR domain consists of 3 subdomains, which illustrate the scenarios associated with encapsulation, header size, forwarding efficiency, and state efficiency. So next page. In this slide, we don't want to give the detailed analysis, but we want to provide the analysis result. And firstly, for the encapsulation header size, the proposals are evaluated against the set of scenarios to calculate the encapsulation and the encapsulation saving. The conclusion is that all the proposal can reduce the size of the SF6 encapsulation header. And secondly, for the forwarding efficiency, there are 2 aspects. One is the parser. The conclusion is that overall, the CC parsers the fewer header. When per packet state is proceed per segment, CC, VC, and UIDSR proposals may include it in the routing header. And the CRH may include it in a destination option preceding the CRH. And the others is about lookup. CC, VC, and UIDSR require a single lookup to process agencies or VPN segment, while CRH always requires 2 lookups for VPN segments and sometimes 3 lookups for agencies segment. all proposals require two lookups to process prefix segment and the next segment. And the third one is please go back. The third one is state efficiency. The compression proposal should minimize the number of the additional forwarding state stored at a node. Our analysis result is that CSAID, VSAID, and UIDSR minimize forwarding state stored at a node. CRH moves per segment state from the packet to FIP. Okay, next page. And let's continue to see the SRv6 based solution. The CSAID is SRv6 based, requiring no update to existing standards. VSAID and UIDSR require some updates. CRH is not strictly based on SRv6, but is able to provide equivalent functionality. For the SRv6 functionality, CSAID support CRH, VSAID, and UID support the functionality or equivalent with some new specifications. Heterogeneous seed list. All proposals support CSAID and UIDSR support heterogeneous seed list in SRH, while CRH and VSAID require installation of building seeds at midpoint nodes. And for the seed list length, all proposals support segment list at least 16 segments. Next page.
Wei-Ching, this is Jim. Sorry to interrupt you. Is it raining heavily in Beijing, or do you have somebody close by you tapping away on their keyboard? Because we can hear tap, 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 tap continually while you're talking.
Oh, I don't know. Maybe there's some noise, but I don't know why. So
Okay. I
yeah,
guess we just
the presentation is almost finished. So I think that yeah.
Okay. I just wanted to bring it to your attention. All right, thanks.
Yeah. Next page, please. Sorry.
Before we go to the next page, Guyan, did you want to make a comment on this part of the presentation? And did you put yourself, because you're in the queue? Yeah, no, I said put us queue on the chat. No,
It's not finished.
I just we can continue probably further down, and when we get to the Q&A section. But yeah, no comments on this.
You'll be on the front of the queue when we get to the Q&A. Thank you.
Okay, thank you.
Yeah. Okay, please next page. And next page, there are the first one is see the summarization. I think the VSAID, CSAID, and UIDSR support segment summarization. CRH doesn't. For the operational requirements, all the proposal can provide lossless compression, non-routing information, flexible IPv6 planning, and scalability requirements. All the proposal meet scalability requirements. All the proposal support 16-bit and 32-bit seed, and all the proposal can be deployed with SRv6 based solution at the same time. And for the security requirements, all the proposal can support the security requirement. So next page. And this page gives the overall result. Shadow shows the relative degree based on conclusion we just mentioned. CSID meet all the requirement items. VSID and UIDSR are less satisfied in forwarding efficiency and SRv6 based. CRH could not support SRv6 based and SID summarization requirements, and less satisfied on forwarding efficiency and state efficiency. Next page. The CSID, CRH, VSID, UIDSR have been detailed analyzed in the design team, and it's time to consider to adopt the related solution drafts from the design team point of view. For the requirement draft and the analysis draft, which provide some useful information for working group, and the text now are stable. Working group can consider to adopt them as informational drafts. The backup pages provide a brief introduction of each section of the analysis draft for your reference. If you want to get detail, you can look into the drafts. I think in order to achieve this point, the design team took more 1 year, and we had more than 100 meetings and exchanged over 1,000 emails. So here, I would like to thank all the members of the design team. That's all. Thank you.
So, folks, Guyan is up first in the queue. Anybody else who wants to speak, put yourself in the queue. Andrew second. Guyan, go ahead.
Yeah, I just had a brief question. How long, what is the timeline, I guess, to finally pick one of the 4 solutions? Also, I guess as far as the final, would it be really picking one, or would there be a combination of multiple solutions as the final, I guess, the end result of the whole design team exercise? I guess to come up with
the working group.
Yes.
What the working group chooses to do is up to the working group. If the working group really wants to choose one, they can. If they want to choose all those for which there are sufficient people willing to work, they can.
Okay.
If they want to make some other choice, well, as long as the chairs can understand it, our job is to do what the working group wants.
Okay. So it's not really tied, it's really driven by the
It's not up to the design team.
Okay. Okay.
Okay, Andrew?
All right. Thank you.
Guys, so firstly, good evening or good morning, wherever, depending on where you are. So I just wanted to make a comment that looking at this, I think that firstly, congratulations on the design team for doing good work. But I do need to point out that, as I've just said on the spring list with regards to our work, a lot of this work seems based on the presumption that all 4 of these solutions are tied to SRv6. There is a very, very high level of binding to SRv6. And I question whether or not a lot of this is valid in the context of where, particularly with CRH, we've explicitly stated that this is a building block and not related to SRv6, with multiple other functionalities being used as a building block, which is why we've gone to the degrees that we have, and we're having prototypes built by the likes of Intel, etc., because we have no need for SRv6. We do have a need for the CRH. And so I would just ask the working group to take cognizance of the fact that this document does seem to base its conclusions and its analysis on a relation to SRv6 that may not be entirely valid in the context of everything else that is going on. So that's just a comment.
Andrew, this is Jim. I noticed Ron has joined the queue. Ron, do you want to? Is your question in? Sorry, are you coming onto the queue to respond to Andrew? Or if not, then obviously I don't want you to jump the queue. But if you are, perhaps you could go next. Ron?
I'd like to amplify what Andrew said. There are some
Okay, go ahead.
customers who aren't interested in the SRv6 control plane, or for that matter, any other control plane. They're driving the whole thing from a controller. Am I still on mute?
Ron?
We can hear you fine, Ron.
Okay. Given that was amplification, I think we need to continue down the queue in order. So thank you, Andrew. Kaur?
Hi, can you hear me?
Yes.
Just wanted to make a real quick comment that looking at the presentation and the materials and the draft, and watching the comparisons in background, it seems like CSEED is almost a superset. Looks like a preferred solution going ahead, at least from an individual point here. Are you going to issue an adoption call anytime soon? A question for chairs.
Perhaps could I give a response?
Go ahead, Wei Ching.
Yeah, so I think the current CSEED draft, which have combined several different solutions, such as microseed, GSeed, and even the basic conception of a VSeed. I think that is a very good solution at this moment. But from a design team point of view, we have analyzed the 4 different solutions, and we provided the results of the analysis. I think for the compromise solution, currently in the working group wide, they are mature. We hope the working group can consider some adoption. And how to do the adoption, I think it depends on the working group decision. Thank you.
Hey, did that answer your question? I know you directed it at the chairs, but I don't want to just brush over it. So an act here would be good.
Yeah, at some point I'd like to understand what chairs are thinking, and and what the timelines are with the issuance of the call. Looks like good analysis has been done, at least from my perspective, and looks like a comparative analysis is looking solid. That's one of the reasons I asked. Thank you.
So
Yeah,
the one thing I
obviously
will,
go ahead, Joel.
the one thing I will say about what the chairs are thinking is we want to know what the working group is thinking. We would really like to see discussion of these 2 drafts on the working group, by the working group on the email list, so we can tell. Because what we want to do, well, we have opinions, I'll grant you. That's not what matters. We want to know what the working group wants.
I think I will reply to that, Joel, with all due respect. The working group is going to be a set of opinions coming from different individual members. I think at some point you
Probably,
issuing a
Chair. We will probably,
Yeah,
the chairs will probably have to make a call, but we'd like to get
Yeah,
some input
thank you.
first.
that would be
Yeah,
helpful.
I think one thing we can clarify, Kaya, is that the chairs haven't made any decision in terms of whether it should be one or multiple adoptions, and we're looking for input from the working group to be able to make that informed decision.
That helps. Thank you so much.
Yep. Daniel, you're next in the queue.
Yeah, do you guys hear me? I think yes.
Yes, we can.
Good. Joe, can you go back the slide just before next step, where we had the summary and the conclusion? Yeah, that one. So the last comment at the bottom, all requirements are not equally important, and the questioning of the fuss about it's more SRv6. So I'm very surprised to see that comment in that slide, because we had a requirement document before doing the analysis that the working group kind of vetted or had like a thumbs up or thumbs down. And to me, like, the analysis document is based on the agreement of the working group. So if they're not equally important anymore after we've done the conclusion, it's kind of weird. Is that how I should interpret that? That we had an agreement on the requirement before doing this analysis. I'm talking to the design team if that was discussed amongst the team before.
Oh, yes. So thank you, Daniel. Charles, couldn't I give a response for this question?
Okay.
Yeah. So I think in the design team, there is no importance assigned. I think maybe for some requirements are a must, and for others are a should. And we provide all the possible requirements from the design team side. And here we list this sentence because there are some members in the design team who have some concerns. Maybe the requirement draft caused some misunderstanding that all the requirement draft all the items in the requirement draft have been given the different importance. I don't think we have done that, and I also don't think it's necessary to do that. So thank you.
Wei Ching, this is Jim. I have to say it caused me confusion as well, because my reading of this slide is either the solution supports the requirement or it does not. And this is saying that, here are the requirements, here are the solutions. These ones support that requirement, these ones don't. Now, obviously, when you choose a solution, it may be that some of the requirements you're not particularly concerned about, and therefore it doesn't matter to you. But the fundamental conclusion here surely is that the solution either meets the requirement or it doesn't. And it's not really a case of whether that requirement is significant to a particular operator or not. Is that correct?
Yeah. So,
okay, thank you.
Jim, I understanding your comment. So, what do you do? You have some suggestion to design team?
Well,
No,
I don't know.
I was just trying to understand it. But go ahead, Daniel. Sorry.
Well, should we go back to the requirement document before we even have a look at the analysis document then? Because I think it was quite obvious that if SRv6 based in this slide is kind of a must, we didn't need a year to find out that CRH doesn't seem to be that is meeting the requirement if SRV6 base was written with must. And to me, it doesn't provide a fair assessment on the four solutions. Is if now we're confused between should and must when we're reading this. So that's pretty much where I'm coming from with this. We're not applying a fair treatment for all four solutions if we only waiting at the end of the analysis to find out that, oh, but this one is a should and this one is a must. Basically, is what I'm trying to say.
This seems a good topic for email discussion by the working group, not for sending back to the design team, for the working group to decide what the working group wants to do with this.
Yeah. Okay. Thank you, Joy.
Then I'm done.
Do you hear me?
Go ahead.
Okay. Yeah, so I'm speaking as an individual. The question is, yeah, what is the working group going to do, and are the chairs going to send out a mail to the list or something like that, or to see what do we want to do going forward with this? And for example, I personally, as a vendor, would like that we select a single solution out of these, because these are heavily data plane impacting, and if we end up selecting all of them, we end up implementing them also. My suggestion would be to select one of them. But how would we do that?
This question is to the working group chairs, right? Wim?
We hear you, but what we want to see at this point, discussion of the content of the requirements and analysis drafts on the list, because we can't, without that, we can't even judge what the right next steps might be.
Yeah, and
Repeating
I think it's also fair to say, Joel, that as part of that discussion, if people want to make specific statements, you know, such as you just made, Wim, then that's perfectly fair to do so on the mailing list. And that's input to us to be able to make a decision as to, you know, what we do as a working group moving forward. But to be fair, at the moment, there's virtually no discussion of either the requirements or the analysis document on the on the mailing list. So it's been, you know, obviously the chairs have got their own opinions, and they may not actually agree with each other from, you know, particular solutions perspective, but it's not, you know, we're trying not to influence this. We want to hear from the working group as to, you know, what do we want to do with these documents? Do, you know, have these documents satisfied what the design team was asked to do, and how does the working group want to move forward? So mailing list discussion is really being encouraged by the chairs at this point.
Okay, yeah. Thanks.
Darren.
Hi. Yeah, all I can really say is just to pile on to what was previously said. It would be great if the working group can come out and pick one of these. I think that as a design team member, we spent a lot of time and a lot of effort, a lot of hours, and a lot of deep analysis that was done very well and very technically true. And I think it'd be great to get the comments on that and validation of that analysis and requirements that was produced by the working group.
Okay, Cheng Li.
A very tough work at the past year. So please go ahead and take a look of the text, and that will help to for the discussion. And since we have multiple vendors have make the make their choose of which solution would be the better one. So we may accelerate the period, the progress of the standard progress. I think because our customers want the solutions. Yep. Thank you.
Okay, thank you. I'm going to close this presentation and bring up the midpoint presentation. I believe this is next on the agenda.
Yes. Hello, everyone. Can you hear me?
Yes, we can hear you.
Okay. Hello, everyone. Today I'm going to talk about SRT past midpoint restoration. Next page. At first, I would like to thank Bruno, AC, Peter, Jeff, and Les for their valuable comments and suggestions on the draft. So we made a couple of changes to the previous version. So in title, we changed protection to restoration. So we use the terminology restoration of routes after load failure, because we restore the routes to the failed node. So the traffic will continue to be sent to the adjacent node of failed node. That adjacent node, acting as a proxy, will forward the traffic around the failed node towards destination. Next page. Next page. So let's have a quick review on the SRT past midpoint restoration through an example. Suppose that we have a SRT path from ingress node B to node N and then to node C. In normal operation, the traffic will send it to P and then to N and then to C. After node N fails, node B will continue to send the traffic to P before IGP convergence. And the node P, after detecting the failure of node N, will reroute the traffic, get around the failure, and then send it to destination C through node N1. However, for the period before, after IGP convergence and before a new path is installed, the traffic will be dropped, because after IGP convergence, the routes to the node N, which is failed, will be deleted from the routing table or forwarding table. The node B will drop the traffic to node N. In order to resolve these issues, this draft proposed restoration of routes to failed node. So this is achieved through node P as a proxy node, advertise its proxy capabilities. The other nodes, such as node B, will use the routes to node P for node N's seat. So with this restoration of routes to node N's seat, node B will continue send the traffic to node P. So after receiving the traffic, node P as a proxy for node N will send the traffic to get around the failure point to the destination. In addition, node P as a proxy for node N will also handle the binding segments on the failed node N. So next page. Let's compare two drafts. So one draft is this draft, another draft is an informational draft. So that another draft we call the draft A, and this draft we call the draft T. So these two drafts have some difference. Draft A talks about using any cast seeds to protect a failed node, and also for protect EPE seeds. Draft T using proxy to protect a failed node. In addition, draft T use proxy to protect binding segments on the failed node. So we can see those are a difference. The overlapping part between two drafts, which is the both drafts try to protect node seed on the failed node. However, even for this common part, they use different approaches. In draft A, draft A talks about configuring route hold timer on each node to hold the routes after a node failure for some given time. So that's the approach draft A proposed. In draft T, we propose using proxy capability. So each node as a proxy will advertise its proxy capability, and then the other node will use the routes to the proxy capability nodes for that failed node. So we can see the approach are different. Because this approach different, the result may be different. In draft A, if some of the node doesn't support this feature, and then the protection may not work. For draft T, if some node doesn't support this feature, the protection may work. So that's about the comparing two different drafts. Next page.
This page seems to have prompted a lot of questions. So
yeah, okay, I can try to answer them. If you have a question.
So, Greg, go ahead.
If I understand correctly, you suggest that because not all nodes may support their timer, then the convergence in a domain will be problematic. But it appears that the same is applicable to this proposal. So it has to be heterogeneous in a domain, so all nodes has to support this. So why you think that all nodes will support this proposal and rather than supporting the timer? Thank you.
Yeah, that's a good question. So the thing is that for example, for configuring every node, so for some of the nodes just support that one in A. So in this case, the protection may not work. For example, one example is that if the shortest path is not on the nodes which support this one, then the traffic will drop in the nodes which not support this feature. However, for draft T, because for each proxy node capability, it will identify the capabilities. So we can select a route which supports on the node which supports that capabilities. So the draft T solution may be a little bit better. That's my point. Because they have more information in the network. They consider the capability nodes, and then they can send the traffic along the nodes which are capable to that until to the adjacent node of the failed node.
Can you hear me?
Yes.
Yeah. So I think my first comment was same what Greg made, that if a receiving router doesn't support draft T, then it's the same. I mean, it won't be able to support the procedure. So I think what you're trying to say is the advantage of T is that if certain PLR doesn't support local failure mechanisms for protecting a node, then draft T has a better approach where it can advertise that information, and then traffic can come to that node which supports being proxy, and then provide protection. So one thing that I would like to note is so far whatever protection mechanisms have been built around segment routing, be it TILFA or micro loop avoidance, and all these are following, I mean, they all follow the post-convergence path and never divert from post-convergence path. Whereas this solution, if there is a certain if all nodes are upgraded, probably draft T also follows that. But if certain PLRs are not upgraded, then it attracts the traffic towards the nodes which are supporting this proxy mechanism, which means that you are diverting from the post-convergence path. So I think what we need to discuss is draft T seems to assume that protection is in certain cases more important than being being compliant to the post-convergence path, and how much important that use case is something that we need to discuss.
Yeah, I think as I answered, same as Greg, I think so. For some of the not support, and then maybe we can even provide some protections. But for the bad one, just configuration, and then may not work. That's my point. And also,
I think most important thing is to discuss, because it diverts from the post-convergence path. That's something that needs to be discussed.
Okay. Shraddha, thank you. Peter, go ahead, and then we'll cut the presentation. Will end after the discussion with Peter. Go ahead.
Go ahead, Peter.
Can you hear me now?
Yeah, we can.
Sorry, I was muted. Okay, I just want to make a small note on what Shraddha mentioned, regardless of, this draft in particular, is that sometimes the TLFA paths may diverge from the post-convergence path, because if you are doing node protection or SRLG protection, then the TLFA paths may not follow the post-convergent path, and it may differ. So it wouldn't be the first case, but it's not that I want to make a particular comment on the draft, but that situation can happen even with the regular TLFA. Thank you.
Yes, thank you, Peter.
Thank you. I'm going to move us on to the next presentation, which I believe is the path protection.
Yes, thank you, everyone.
I had trouble matching file names. I believe this is the next presentation.
Hi, can you hear me well?
I can hear you.
You can, go ahead.
I think the next presentation is SRv6 midpoint protection in the agenda. If I because based on the agenda, the presentation is SRv6 midpoint protection, and the slides presenting now is the next presentation. Okay, this is the correct. Thank you. Thank you. Hi, this is Xue Song from Huawei, and I will introduce our work about SRv6 midpoint protection. Next slide, please. So why we need an SRv6 midpoint protection? When there is some failure in the transit node, we could use FR mechanisms such as TIFA. But when there is a failed node in the endpoint of the SRv6 path, the existing FR mechanisms cannot be used to restore the reachability. Yes, SRv6 end-to-end protection could work in this case, but we think a simpler and faster local repair mechanisms is also requested. There is some work has been done in Spring working groups such as Spring segment protection, SRTE pass. It could provide endpoint protection for SRM MPS case. And the goal of this document is to provide an SRv6 midpoint protection in the SRv6 network. When an SRv6 endpoint fails, an SRv6 proxy forwarding node can replace the failed endpoint to perform SRv6 endpoint function and forward the packet to the right destination. Next page, please. Actually, the mechanisms is quite straightforward. In an SRv6 TE pass, if an endpoint is failed, the midpoint protection could be divided into two periods. In the first period, before the IGP has converged, when the repair node is adjacent to the failed node and finds that the failed node is an endpoint, it will perform proxy forwarding and send packet to the next or some reasonable endpoint in the segment list. And the second period after IGP convergence has happened, any upstream node that has been converged and deleted the FIB to the failed node will be the repair node and perform the proxy forwarding action and send the packet to the next endpoint or some reasonable endpoint in the segment list. After the convergence of SRv6 policy, the node forwards the packet along the converged path, and the local repair will end. Next slide, please. In the document, we specify the SRv6 midpoint protection behavior. Basically, when the repair node is a transit node or an endpoint node, the behavior is the same. It is divided into two cases as I have explained in the previous slide. The first case is when the node is adjacent to the failed node, and the second case is the node is a remote node. And the behavior is similar. Segment left decreases, update the IPv6 destination and the FIB lookup on the updated destination address, and forwarding the packet according to the matched entry. And when the repair node is an endpoint.x node, the repair node could only be the neighbor of the failed node and do similar behavior. Next page, please. So actually, this is the some simple plan for this document. This document has already been presented in RTGWG for several times, and we collect some feedbacks and update the document. The authors believe the document is stable and has been fully discussed. So we plan to collect feedback in spring because there is some similar work discussed here, and we will ask working group adoption in RTG. Any questions or comments are welcome. Thank you.
Greg, go ahead.
Thank you for the presentation. I have a question. So, the node that provides the protection is expected to have a state and notion about their edges and their capabilities so that it can select, if detected, the node. Actually, my question is like twofold. First is how this node that switches to another egress knows that the alternative is still capable and can be used. It's a more, another question is a more like generic and philosophical probably. Why you propose to use local protection for this rather than to have end-to-end protection, so not to create the state in a transit node and let their ingress node to do the switchover if something fails. Thank you.
Thank you, Greg, for your question. For the first question, if I understand this right, it is about when we find an endpoint has failed, we switch to another endpoint to forward the packet. How does the node know that the other endpoint is still work? If I understand this right, is that your question?
Yes, because if you're switching to an to node which is not working or cannot be reached, then so there is no benefit.
Actually, this is another case. When the existing node find its neighbor has failed and the neighbor is the endpoint, it will switch the destination address to the next endpoint. If the neighbor of the next endpoint finds that the endpoint is also failed, it will switch to the next endpoint. So that is another behavior after this, because the first thing you will find that my adjacency has failed and it's an endpoint, and if some other nodes find that the switched endpoint is also failed, it could do the similar thing to forward the packet, unless this is the last endpoint. Is that answer your question?
Yeah, to some extent.
Yeah, the next question is why we won't use end-to-end protection. Yes, end-to-end protection will work, but we think end-to-end protection maybe have their limitations, such as it depends on BFD or some other detection mechanisms, and also local repair will be more fast. And in some case, maybe vendors will like to see the packet won't last for a long time. So we think local repair is also requested.
Well, I probably would not agree that local protection would not use BFD because
yes,
I would imagine that there needs to be some mechanism to detect that the neighbor
Yes, you're right. It
cannot.
depends. Mhm.
Yes, but again, there could be scenarios, but I think of scenario where BFD must be used, so you cannot really rely only on link layer state, like an optics fail.
Yes, maybe the detection is still needed, but at least it will be faster.
I don't think that's the case because regardless whether it's a single hop or multi-hop, BFD can be used aggressively and detect diff failure at the same time. So I don't see much difference between single hop or multi-hop, and that's been used in the networking for a long time.
Actually, it's just like TFA. If we use TFA for the transit node, we can to treat it as a local repair mechanisms. We could use this endpoint protection for the endpoint as local. If we think TFA
I understand.
has their scenario, this work I think has its scenario.
Yes, I understand, but I don't really agree with the approach that Hammer sees everything as a nail. So not necessarily the same method works in all scenarios. But okay, thank you.
Thank you.
Bruno, you're next, and then Robin, and then we'll close the queue there because we, in the interest of time.
Bruno speaking as individual contributor. Could you move to slide 4, please? Thank you. So the slide is not very readable, but my understanding is that the transit node is a regular IPv6 node doing IPv6 routing. And you are proposing that the transit IPv6 node is changing the IPv6 header, both destination address and SRH. And this could be seen as a violation of RFC 8200. So what's your position on that?
Actually, in my understanding, when the TLFA works, and it will just like to have a new SRv6 encapsulation for the packet to build up a new tunnel to the next destination. I think it is similar. We has to make the repair node has some extra capability to complete the protection. If it is just a simple SRv6 node, it can do nothing except for forwards the packet based on the destination address. So I think that is necessary for the protection mechanisms.
Well, for TLFA, for link protection, you probably don't need to change the header. You do an encapsulation to the regular next step. And indeed, maybe for node protection, you need to do something.
Yes, you are right. The transit node may be requested to change the SRv6 header, but we think it is in the limited domain, and the transit node is also trusted. So we think this may be reasonable to give it some capability to do this, and the mechanisms can be complicated if the scenario is reasonable.
Maybe this would need to be discussed in 6 months because it's a change of 8200.
Sure, we can also bring it to the list, and we can also forward it to 6man to guarantee that this will work.
Okay, thanks.
Thank you.
Robin?
Hello, this is Robin. Can you hear me?
Yes,
Hello?
we can hear you. We can hear you, Robin.
Okay. I just add an explanation to the Greg's comments. I think the BFD is used for the link local for the local protection, and this is just the one link is just one BFD session. But if the BFD is used for the end-to-end failure detection, that will be per pass. That means for every SR pass, there will be a BFD. So that will increase the deployment burden. So I think that's the challenge of the end-to-end detection. The second one, I think the BFD for the local detection, I think the detection period can be shorter. But if the BFD is used for the end-to-end, that the timer need to be set to a long value. So that's also is this case in the practice. Okay.
Thanks, Robin. I actually closed the queue, Greg, because we need to move on to the next presentation. Perhaps we can take that comment or that discussion to the mailing list.
Hi, this is Yao. Can you hear me?
Yes, go ahead.
Okay. Our presentation today is about BGP extensions of SR policy for segment list protection. Next slide, please. It is introduced in SR policy architecture that candidate paths may be used for path protection, and SR policy allows for multiple candidate paths, but only one active candidate path can be provisioned in the forwarding plane and used for traffic steering at the same time. So another candidate path may be used as a backup. In order to specify the protection relationship between candidate paths, configuration or local policy may be needed on head-end. And the backup candidate path provides protection only when all the segment lists in the active candidate paths are invalid. Scenarios like load balancing may need segment lists for protection. For example, CP1 is the active candidate path. The flows are load balanced between segment list 1 and 2. And CP2 will take place only when both list 1 and list 2 are invalid. We may want to protect list 1, so after list 1 fails, flows can still be load balanced between list 2 and the backup list of list 1. And the protection relationship among segment lists should be flexible. And there's already a working group document in PCE that proposes extensions to PSEP to provide backup segment lists for protection. Based on the above considerations, this document mainly proposes extensions of BGP in order to provide path protection using segment lists when delivering SR policy. Next slide, please. And this slide shows the BGP extensions. If the B flag in segment list sub-tier V is set, it indicates that the segment list acts as a pure backup path. And the list identifier sub-tier V is used to identify the segment list. And it contains an optional sub-tier V, the list protection sub-tier V. It carries the protection relationship of segment lists. The rightmost figure shows the position of the new defined tier Vs in the SR policy, NLI. Next slide, please. And this draft also proposes extensions of BGPOS. The TELSP distribution draft describes a mechanism to collect the SR policy information that is locally available in the node and advertise it into BGPOS updates. It includes a candidate path state TLV and the segment list TLV. The S flag and B flag are originally defined in Kennedy path state tier V. And two new flags of similar meanings in segment list tier V are defined in this draft. The S flag indicates that the segment list is in administrative shut state, if set. The B flag indicates the segment list is the backup when set. Next slide, please. And this draft has been presented in the IDEA working group before, and we request feedbacks and comments. Thank you.
Move on to the next item on the agenda. Not hearing any. I believe this is the next. I believe this is the next one. Go ahead.
Hi, my name is Gian Mishra. I'm with Verizon. Can everyone hear me? Okay, I guess that's a yes.
Yes,
okay,
we can.
Thank you. Okay, thank you. Yes, hi, my name is Gian Mishra. I'm with Verizon, and I will be presenting segment routing, an extension to segment routing to provide redundancy protection. Next slide. So this draft provides an extension to segment routing to provide redundancy protection. It utilizes the DetNet framework architecture to provide ultra-high lossless transmission of data. So it provides a variety of use cases where redundancy protection is required, where there's ultra low loss of traffic, and utilizing the DetNet framework, that architecture. We introduced two new SID types, service SIDs. So there's a new replication SID, which performs the RF function, the replication function, in the DetNet framework, and a new merge SID, which is at the egress node, that provides the PEF elimination function for the overall pre-off framework, providing that function. So with that, the goal of the draft is to be able to provide ultra high transmission of traffic and flows by duplicating the packets and then eliminating the duplicates at the merge point to provide lossless data transmission. So in this diagram here, we're showing just an example with SRv6 redundancy protection and how that would work. So with SRMPLS, it is very similar, that you would have a redundancy node where you have a replication SID where the packets are replicated at the redundancy node, where two or more copies are created. Each replicate is transmitted via different disjoint forwarding paths that may occur along the path at the top and then a path at the bottom. And then at the merge point, we have a second service SID, a merge SID, which actually does the elimination, provides a PEF function, DetNet framework PEF function, to eliminate copies of duplicates, and then provides a lossless transmission from ingress to egress. Next slide. So some history. So at IETF 104 and 105, This draft was presented in DetNet work group as the DetNet SRv6 data plane encapsulation. At IETF 106, this was presented again at the DetNet work group. Was suggested to take the presentation, take the draft to spring. And then after that, in IETF 109, this draft was presented again, but presented now in spring. And the proposal was redefined and as a general protection mechanism, and basically like a live protection. So really, the architecture, it was based initially on the DetNet framework. However, the single use case was what the framework was based on, but now this is the draft is really more of a ubiquitous, where in any use case where ultra high traffic flows, where ultra low loss flows are required, such as 5G or network slicing, where low loss traffic is required, high QoS and availability, video, voice, video, or whatnot, where there are cases where that might be required. The solution could provide the framework for that, and it could be a solid solution for that. Next slide. So the draft structure. So the scenario of redundancy protection in SR. So we, as I mentioned, we have two new segments that were introduced for redundancy protection. So we have the redundancy segment that's at the ingress node, and then a merge segment at the egress node. So the redundancy segment within the DetNet framework is providing the packet replication PRF function, and at the merge segment providing the packet elimination function for pre-auth. And metadata to support redundancy protection is supported as well. Segment routing policy to support redundancy protection as well. So that is supported as well to provide that with SRTE. Next slide. So techniques to support redundancy protection. So with redundancies, the segment to perform packet replication function on the redundancy node, a BSID associated with a redundancy policy, a variant of the SR policy to steer the flow. In the case of SRv6, we define a new n.r end function is defined for SRv6. For the merge segment, to perform the packet elimination function on the merging point is the goal of the merge segment. In the case of SRv6, we have a new behavior defined at n.m for merge is defined for the SRv6 programming. Encapsulation of the flow ID and sequence number. So there's a flow identification to identify a unique flow that will be replicated at the ingress at the redundancy segment, and then with that sequence number eliminated at the merge segment. The sequence number is there to identify the packet sequence within the flow for the overall pre-auth function to work. So the redundancy policy includes more than one ordered list of segments between the redundancy node and the merging node. So all of the ordered lists of segments are used at the same time. Next slide. So on the left, the programming, programming for the redundancy segment for SRv6. So when SRv6, when the SRH is processed with SRv6 programming, first, so the standard processing happens. What's included in addition is the allow in blue at line SO6 and SO7 to allow flow identification and the sequence number if indicated, and then duplication of the packets as the number of active SIDs listed in B. So at the beginning of the flow, during the processing, once the flow identification happens and the packets are duplicated, then the standard processing happens, similar to any other topological segment. On the merge side, on the merge segment, the same thing here. The standard SRv6 processing occurs with the initial when the SRH is processed, what's added in there is in blue. Acquiring the sequence number of the received packet and look up in the table, and if the sequence number doesn't exist, sorry. If you go back to the last slide, sorry. I was still, can you go back to the last slide? Thank you. So if the sequence number doesn't exist in the table, store the sequence number in the table. So at the merge segment, basically what we're doing here is it's similar to the DEDNet architecture where the sublayer is a service sublayer function is really what's happening with the service segment with the redundancy and merge segment where we have sequence numbers. So we have a sequence number that we're matching on the traffic flows, and that sequence number is actually matched at the merge segment to determine which flows and which packets are duplicates that need to be removed at the merge segment. So that's really the key there. It's really in this framework, it's providing the that service sublayer function in tracking each flow with a sequence number and determining which packets to be removed at the merge segment. Next slide. So packet walk with SRv6 redundancy. So how the flow would happen. So going from left to right. So we have at R1 we have our ingress node, and then node R. So at the source node, the SRv6 SRH header is added at the source node, and then it's forwarded. The headers the SRH processing happens, and the packet is forwarded along the steered path. The packet hits the redundancy node. So at the redundancy node, the replication SID is processed. So at that point, the sequence number is added into the SRH header, and the TLV is set for the F label and S label per the DEDNet architecture, RC 9025, and then the packets processed, received at the merge node. So at the merge node, the sequence number is matched, and there when the service said the merge node, the merge segment is processed, the sequence number is matched, and then duplicates within that sequence number are eliminated. So performing basically the PEF function within pre-auth, and then the packet is forwarded to the egress. Next slide. So addressing received comments thus far on the mailing list. So the first one, what is the location to add the flow ID and sequence number? So we've had an agreement that there is an advantage to add the FI and SN at the ingress node. So that has been updated in revision 4.
Guy, and this is Jim. I'm sorry to interrupt. You've got maybe 1 more minute.
Okay.
Yep, sorry.
Right.
We're going to run out of time otherwise for the other presenters. So
if
you could try and wrap this up. Yep. And there's a couple of
Yep.
questions as well, so I want to give them time.
Okay, we'll do. All right, the next one is where it's deal with replication SID and redundancy protection. So clarification on the modification of the replication SID. Number 3, clarification on the redundancy segment with multiple paths. So clarification there, and then flexibility with the redundancy segment to be topological or service SID. Now, good. Let's go on to the next slide. So relationship to DEDNet. So there has been some conversation back and forth with on the DEDNet architecture and whether the implementation of the redundancy redundancy protection and whether it violates or if it follows the DEDNet framework. So we've had some feedback back and forth related to that. So redundancy protection it's a generalized mechanism. So we're using the framework, but it can be used. There's any use case where you need ultra low loss, across it for any type of transmission. It can be used for any solution, any use case such as that. And DEDNet is another use case that it could be used for since it was built based on that framework. 1+N protection, ultra high reliability for segment routed networks, ultra reliable protection in many use cases. So any use case where you have voice, video, or where you need ultra high reliable data transmission across a segment routed network, where at low loss, this could be a good use case for that. Next slide. So drafts revisions since IETF 110. So use case clarifications, so targets to provide ultra reliable transmission. Add more use cases. We did some reorganization with the SRv6 scenario, and then flexible place to add flow identification and sequence numbers at the ingress. So we decided, updates in section 3 and 4 for the ingress node and redundancy node, and then changes to the segments, the pseudocode accordingly in section 4. And regarding segment usage in SR over MPLS, referencing RC 8964 in section 4. And lastly, a separate redundancy policy specification, so spinning off into a possibly different draft, section 6. Next slide. So we'll take some more discussions onto the mailing list, and we want to get feedback from the work group through the changes, an update since the last IETF 110, and now whether how the work group feels about the draft and the use cases. We've expanded the use cases, so it's not geared just for DetNet, even though the framework is based on DetNet, based on the pre-op, but we're leveraging DetNet, the architecture of DetNet, to be used for any use case where you have high where you require high transmission and really low or zero loss of traffic, zero packet drop. So thank you.
Thanks again. So Greg, if it's quick, I'm going to allow one question because, in fairness of other presenters, I want to make sure they've got time to give their presentations. So if you can go ahead, Greg, but I'm going to have to cut the queue after you.
Okay. So what I would suggest is analyze why this method is more beneficial than just 1+1 protection. When you select the working source and the protection source and do the switchover not per packet but by source. Thank you.
Thanks, Greg.
Okay, sorry everyone else on the queue, I'm going to have to cut it there. If you can take your questions to the mailing list. We need to get on. We've got 3 more presentations and I want to make sure they get time. So Joel, next presentation, please.
Hello.
Yes, we can hear you. We're just waiting for the slides to show.
Okay.
End of the presentation I'm looking for because I've been having trouble finding it. So just tell me the title.
It's the SRH and IP header protection. Draft Chen Spring SRv6 SRH security.
Yes.
I believe it's this one.
That's it. Yep.
Yes.
Thanks, Joel.
Hello, this is Mei Ling Chen from China Mobile. We propose a method for segment routing, header, and IP header protection based on asymmetric keyings. Next slide. In FC 18.7.14.15.4 defines SRv6 HMAC TLv4 IPv6 source address and segment routing header integrity protection. This method may bring a problem because HMAC verification is based on symmetric keying. That means all network nodes need to be verified, have to share the same key. So when a single point key was leaked, then all the trust domain was compromised. In my draft, we present an alternative method for segment routing header protection. based on asymmetric keying. My presentation slide will present 3 parts. Next. Next slide. The first part, we define a new type for TLV, which called OS TLV. The TLV is used for signature protection based on asymmetric secret keys and used to protect source address and header. OS key ID is a 4-octet opaque number, which identifies the hash signature algorithm, and certificate serial number used for signature authentication, and OS will be used to store the signature content. OS is to protect segment routing with 6 header, but also protect GSW with 6 header. Next slide. The second part is signing and the verifying process using a new TLV. That's the core content of my draft. The process is divided into 3 steps. The first step is preset certificate for controller or source node. Step 2 is perform public key certificate distribution and the signature algorithm selection. Then, after the selection is finished, inform the key node selection result. Step 3, controller or source node use the private key and hash algorithm, asymmetric algorithm to cite the pocket header and signature results. The signature results will start in the TLV. Next slide. In part 2, how to verify signature. Always signature verification is required at key network nodes. It also divided into 3 steps. First, enable. Enable signature verification at key nodes. Not all the nodes will do the verification. Step 2, request the public key certificate from the controller. Only the key nodes who want to verify the signature will request a public key certificate. Step 3, calculate the hash value according to the header and use the public key to decrypt the signature. Finally, make these 2 values compared. If equal, then forward. Otherwise, discard. Next slide. Thank you. When used a symmetric way, it will sure affect the processing efficiency. We have a tip for optimization. How to say in a word, use a local hash table to record the history data. So when some hash value is found in the table, then no need to do more decryption. It can save the computer's resource. In this way, we'll optimize the process. Next slide, thank you. That's the core design for my draft. If you are interested in my draft, please read the whole draft because it's more detailed than this presentation slides. The presentation is only 10 minutes. Comments are welcome. Thank you.
Thank you. Ron, go ahead. Ron, you have a question?
Hello, Ron.
Sorry, I was on mute.
Okay, go ahead.
2 quick questions. First, many fields in the SRH are mutable. How does your solution deal with mutable fields? And second, why is this preferable to just using the authentication option in IPv6?
Thank you, Ron. It is true that segment routing header it can contain many different values. In our we just covered the several key value key parameter in the segment routing header, such like source address, and the second question is I from my point understand you care about the key point because most of the points are muted. Is that right?
So which are mutable.
Which are Sorry, I don't get the key point of your second question. Can you discuss this question on my on the mail list?
Okay, we'll put it on the mailing list.
Thank you very much.
Okay, no more questions. Thank you, Mei Ling. Joel, next presentation.
Thank you very much.
Hello, everybody. Can you hear me?
Yes, we can. Go ahead.
Okay. Yeah, this is an update about the SRH encapsulation for alternate marking method. So next slide. Yeah, I'm going to present this update. So alternate marking is defined in two documents, RFC 8321 and RFC 8889. There is already a document that defines a new TLV to be encoded in the IPv6 option header, both hop by hop and destination. And the scope of this draft is to use the same TLV to be carried as SRH TLV. We believe that for SRv6, it may be preferred to use the SRH TLV for a number of reasons. And while, of course, for all the other cases with IPv6 data plane, the use of hop by hop and destination option may be preferred. So next slide. Yeah, so as I said, the alternate marking data field that we are going to extend here for the SRH TLV is basically the same that we have defined for IPv6, for the IPv6 options header. So we have the 2-bit, that is the loss and delay bit, also called marking fields, and flow monitoring identification that is required for some deployment reasons, to reduce the node configuration, to simplify the counters handling, and to also to facilitate the data export. This field can be assigned by central controller or pseudo-randomly generated by the source node. In this case, there is a probability of collision, but this is further discussed within the draft, and there is no time to discuss here. So next slide. So the use of this TLV is quite simple. So the ingress node is the only one that can write this TLV and may add the alter mark TLV in the SRH if this functionality is supported, of course. Regarding the intermediate and egress node, they can only read this TLV. And if an intermediate or egress node are not capable of processing this TLV, they can simply ignore it. It is worth highlighting that if there are nodes that are not capable of processing this TLV, this is not an issue, because the measurement can be done only for the nodes that are configured to support this TLV. Next. Yeah, in this slide, we just highlight the changes from the 0.0 version. According to a discussion we had in 6 months, we had the new section on controlled domain, because RFC 8799 introduced the concept of specific limited domain solutions, and alternate marking is considered as let's say, an innovative approach, an innovative extension to IPv6 that, for some reasons, such as policies, options supported, security requirement, it is strongly suggested to limit this kind of application to limited domains. And so we added this requirement also in the context of SRv6. The second change was the revision of the security consideration section. So according to the discussion we had in 6 months, we also clarify several statements in this draft to highlight that the alternate marking must be applied in the context of a controlled domain where a network administrator can select, monitor, and control the access to the network. Next. Okay, next step. So, yeah, this is a straightforward way to apply QRFC to SRv6. The companion document is in last call. We also welcome questions and comments and ask the working group to evaluate the adoption if it is considered a valuable work, of course. Thank you.
Ron, go ahead.
Thank you for this work. The IETF has defined a small handful of routing extension headers. If you want the alt mark to be available only to the SRH, you might consider putting it in an SRH TLV. If you want it to be available to all routing headers, the right place for it would be in a destination option that precedes the routing header. Why did you choose the SRH as opposed to putting it in a destination option that precedes any routing header type?
Yeah, this is a good question, because as I said, yeah, in 6 months we already defined the same option, the same TLV that can be encoded as destination option. So in this case, it is applicable to all the routing header. But with this draft, we only apply as a SRH TLV, because, of course, for the case of SRv6, it may be preferred the use of SRH TLV, because, you know, in some cases, the destination options are not well supported. And maybe in the future, if SRv6 will be used, also the SRH TLV can be also the best approach to be used only for the case of SRv6. But for all the routing header, the use of destination option is the best one.
Already allowed in a destination option that comes at the end of the extension header chain. Isn't it also allowed in one that comes before the routing header?
It is basically the same behavior, of course, because if you have the destination option preceding a routing header, and in this case preceding the SRH, it can be considered for all the for all the SR node along the path. So it is absolutely the same behavior of the SR-HTLP. So yeah, and we also mentioned this within this concept in our draft. So it's just you have a double option. So it depends on how it depends on what will be implemented. If the SR-HTLB will be really implemented, will be used more than the destination option, it can be a preferred option. But yeah, for now we have the double option to choose.
Okay, no more questions. So, so last presentation, Zichang. I hope I pronounced that correctly.
Can you hear me?
Yes, we can.
Okay, I'm Zichang Li from China Mobile. I will present the draft on behalf of the co-authors. Next slide, please. BFD can be used to monitor passes between nodes, and SBFD provides a simplified mechanism which is suitable for monitoring all passes that are set up dynamically and on a large-scale network. But when SBFD use SRv6 data plan, and if we hope the SBFD pass round trip symmetrically, if we want the SBFD packet goes symmetrically, we need, especially in the SRv6T scenario, the SRH header will be the SRH header will be double length long. So this draft we describe a method to simplify the implementation of SBFD over SRv6 by using SRH flag label to instruct the SBFD peer node to do swap operation of SRv6 seed list. Next slide, please. This is the procedure of SBFD over SRv6. We categorize the network node into three kinds. That is init node, intermediate node, and reflector node. The init node encapsulates SRH with seed list and send the SR handler flag bit 5 to 1 to indicate the reflector node need to do a swap operation, and the intermediate node just do the normal SRv6 forwarding behavior, and the reflector node check if the destination address is itself, and if the SR header flag bit 5 is sent. If the condition is satisfied, then the reflector node will do the swap operation besides the normal SBFD procedure. Next slide, please. This is more detail about the procedure. In the picture, there are 4 nodes, and switch A is the init node, and it will push the seed list A, B, C, D in the SR header, and set the SR header flag bit 5 to 1. When the SBFD packet travel to the switch D, that is the reflector, switch D will do the normal SBFD operation, and it will swap the seed list to DCBA. Then it will set back the SBFD packet to the init node. Next slide, please.
Zicheng, this is Jim. We're going to run out of time, so if you can quickly wrap up. And Greg, if you don't get cut off, then go ahead with your question.
Okay, this is just a conclusion. In the draft, we just reuse the SR header flag bit file to indicate if the reflector node need to do the swap operation, and the reflector node just need to support the swap operation. This is clean and tidy. Next slide, please. Next slide, please. Oh, okay. We collect, we require comments and seek for collaboration. Thank you.
Question?
If I may, I noticed that the draft is tagged as informational, but it looks like you are requiring allocation of one of the fields in the flags to do the reversal of the seed list. And
yes.
in other words, probably more generic is that I think that similar can be achieved if you concern with their length of their seed list with a binding seed, and then it would be applicable to both SRv6 and SRMPLS. Also, the concern is that SBFD is not defined for multi-point networks, so that I wonder if you plan address only point-to-point SR policies or point-to-multi-point SR policies as well. Thank you.
Okay, thank you. This is an interesting question. For the first draft, we just consider the point-to-point scenario. Maybe we will refresh the draft, and in the next draft, we will consider more scenario like the P2 MP scenario, and we can talk in the mail list.
Okay, thank you. I guess that's it. Thank you, everybody, for attending.
Thank you.
See you next time.